Now, these problems can be fairly tricky, so let's do several more examples. So for this one, we have g of x is x squared minus 4x minus 21 over x plus 13. And let's start by just determining which x value is not a part of our domain here. And we can just say that our denominator, x plus 13, it cannot equal 0, since then we would be dividing by 0. And let's just solve this. So we'll subtract 13. So we get that x is not equal to negative 13. And you can see that's one of our choices here. So this is either a vertical asymptote or a removable discontinuity. But to answer that question, we'll need to factor this numerator here. So let's start doing that. We can rewrite this as a product of two binomials since it's a quadratic. And the denominator stays the same. Let me redraw that. We still have x plus 13. Now, these are each going to be binomials, so they'll have two terms each. And since the coefficient on x squared is 1, we won't have to use a grouping method here. We can sort of use a FOIL method in reverse. And so these first two terms, they need to be x and x, since that's the only way they can multiply to get x squared. And then we just need to figure out these constant terms. These are just numbers. And these numbers, they're going to multiply to negative 21, and they're going to add to this negative 4 here. So let's write out a list of possible choices. So what numbers can multiply to negative 21? So we have the numbers minus 1 and 21, or 1 and minus 21. We can do 3 and minus 7, or minus 3 and 7. And we're looking for which of these pairs would add to negative 4. And you can see that 3 and negative 7 would give us negative 4. So it'd be x plus 3 and x minus 7. Now you can check this by just remultiplying it out. So if we distribute the x, we get x squared minus 7x, then we get plus 3x minus 21, and that would simplify back to what we had. So if you don't feel like you have mastery of those, I recommend checking that every time you try and factor. Now what we can notice is that we don't have an x plus 13 up top. So we can't make any type of cancellation there, which means that negative 13 is a vertical asymptote. Remember, to get this removable discontinuity, that you have to be able to make a cancellation with a factor in the top and the bottom. And these other two values, negative 3 and 7, notice that if we plug in negative 3 here, that would make the function equal to 0, since we can use that zero product property. So if let's do that formally, we'll plug in negative 3, and so we get 0 multiplied by negative 10 over 10, and 0 times anything is 0. And likewise, if we plug in 7, we get 10 times 0 over 20, but that's also going to be 0. So it looks like both negative 3 and 7, those are the zeros of our function. And just to get more practice, let's put this into our graphing calculator and verify that all of this is correct. So we'll go to y equals, we'll put in our original function. Let's do x, and actually we need to put it in parentheses so that we have the entire numerator divided by the entire denominator. So we have that x squared minus 4x minus 21, close parentheses, is all divided by x plus 13. And let's just do a standard zoom and go from there. We might have to adjust this. So we need to be able to see negative 13. So I'm going to change the window, and we want, let's say, an x minimum of minus 15. So that will guarantee that negative 13 is in our window. And we can graph this again. And it still seems like we're a bit too zoomed out with our y value. So let's just zoom out here. And notice, by the way, that we do have zeros at negative 3 right about there. If we scroll over, that is roughly negative 3. And we got a 0 over here, which if you count, that's at 7. So the zeros did make sense, but now we got to zoom out roughly around our asymptote so that we can see if it truly is an asymptote. So we'll zoom out there. And let's zoom out again since we're still not really seeing it. So once more, and there we go. Now we can finally see the entire graph. And you can see that the graph before, if we trace, and let's say we're looking at minus 12 or so. So if we're really close to negative 13 on the right side, it shoots up to a very high positive value. And let's say if we put in negative 14, if we're very close to our asymptote from the left side, it shoots down to a very negative value. So you're always going to see this break in the function when it's an asymptote. And as we saw in the first example, when it's a whole, it won't even look like anything is missing until you try and trace and then actually plug in that point, and you won't get a y value there because it's not defined. So with the calculator, we checked, and this did make sense.